Xinan Chen from Applied Math and Statistics will talk about how do neurodegenerative diseases affect our brain.
Human brain is very active. It consumes 10 times more energy than the rest of the body. Along with its highly intensive activities, the brain produces tons of wastes. This predicts a very efficient system to remove these wastes and clean the brain. A hypothesis of how this cleaning system works very much resembles washing a sponge. Just like the left-hand side of this picture, imagine the brain as a dirty sponge. Our body will produce a liquid to constantly enter the sponge and wash the dirt out. But according to my findings, this cleaning system doesn't work if the brain is sick. I find that in brains with neurodegenerative diseases, such as Alzheimer's and Parkinson's, the majority of this flushing liquid does not actually enter the brain, but instead, the liquid gets redirected away from the brain. Imagine the sponge again, but this time the holes within the sponge somehow get plugged. If you open the tap trying to wash the dirt out of it, the water cannot get in, and so the dirt stays. Similarly, with the products in diseased brains will also stay, and they will quickly build up and may permanently damage the brain. These findings are based on experiments on rats. We injected chemical tracers into the necks of both healthy rats and those with neurodegenerative disease. We later scanned their brains every 5 minutes to collect image data. Then I applied our mathematical method using equations in fluid dynamics to reconstruct the behaviors of the fluid in brain. Compared to traditional medical imaging tools like MRI, our mathematical method provides a brand new way to observe what happens inside of the brain. In particular, it allows us to visualize the trajectories of the fluid flows, and most importantly, to measure the fluid speed in brain, which conventional methods are incapable of doing. Neurodegenerative diseases like Alzheimer's and Parkinson's affect millions of people on this planet, but the mechanisms of these diseases are still poorly understood. Currently, there's no way to slow down the disease progression, and no cure has been found. My findings improved our understanding of these diseases and further suggest that to restore the normal fluid pathways into the brain could be an important approach for treatment in the future. This work was published in Nature Aging this year. Thank you for listening.